Hello everybody and welcome back to more of the 2005 Euclid contest. It's Root Beer here, and we're going to be going through question number 4 in this video. So we have a light bulb and a written part. Part A. 6 tickets, numbered 1 through 6, are placed in a box. 2 tickets are randomly selected and removed together. What is the probability that the smaller of the 2 numbers on the tickets selected is less than or equal to 4? Okay, so it's a basic probability question. We've got tickets, we're removing them from the box, and to do with this sort of a probability question, if we want probability, we count the number of outcomes we desire, divided by the number of outcomes that are possible. So how does that break down for this question? So this is the number of ways to draw 2 tickets with probability that one of the smaller of the 2 is less than or equal to 4. So that would just be one ticket less than or equal to 4. It could be both tickets, but the point is we just care about the probability that at least one ticket is, over the number of ways to draw 2 tickets. Okay. Now there's a couple ways we could approach this one, but we're going to need to figure out the number of ways to draw 2 tickets overall. So how can we do that? Well, you could start by saying, well, you could draw the 1 and the 2, you could draw the 1 and the 3, you could draw the 1 and the 4. Notice that drawing the 1 and the 4 is the same as drawing the 4 and the 1, so we don't count that. So you could go about this, but you realize you're going to be writing a lot. I mean, we've just gotten through everything that had a 1. Alternatively, you could say, well, okay, if 2 is the first one, you can either have 3, 4, 5, or 6. So that's 4 possibilities. Up here was 5. You might guess the next one's 3. There's lots of ways you could do it. Another thing you could do is you could say, well, how many ways are there to pick the first ticket? Well, there's 6 tickets to pick. And then, hold on. Before I go into this one, let's at least finish one of these counts, and then we'll compare them. So if we had a 3, we could have 4, 5, or 6. If we had a 4, we could have a 5 or 6. And if we had a 5, we could just have 6 as the other ticket. And that way we're not counting anything, because we fixed the lowest number first. So 5 plus 4 plus 3 plus 2 plus 1, 15 ways to draw 2 tickets. Okay? So, as I was saying, there's another way we could view it. How many tickets are possible for the first ticket? Well, 6 of them. How many tickets are then left after we draw the first one? It's 5 tickets. But, as I already mentioned, picking 1 and then 4 is the same as picking 4 and then 1. So we're going to double up on our ticket grabs here. So we divide the whole thing by 2. 30 over 2, 15 ways to get the tickets. Either way you do it is fine. So that's going to be our bottom number. It's going to be something over 15. Number of ways to draw 2 tickets with at least one of the tickets being less than or equal to 4. Now you can either count them and say, well, okay, here's one where we've got something less than or equal to 4, here, 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 here. You're going to find pretty quickly that just about everything except for 5 and 6 can be done. Now you might count them out, or you might be able to say, well, suppose I didn't have 2 tickets with at least one being less than or equal to 4. That means both of my tickets have to be greater than or equal to 4. That forces the 5 and 6. So out of these 15 ways, only one of them is not going to have one of the tickets being less than or equal to 4. So we could do 15 minus 1, or 14. So that's another way to view it. But ultimately, we get our probability, 14 out of 15. And that's what we'd write down. It's a light bulb, so if you just want to get to that answer, that's fine. Okay. So the light bulb's done for question 4. Now, for B, a helicopter hovers at point H, directly above point P on level ground. Lloyd sits on the ground at point L, where HLP is 60 degrees. Okay, so already I'm seeing a 30, 60, 90 triangle, which pops up from time to time on these contests. A ball is dropped from the helicopter. When the ball is at point B, 400 meters, directly below the helicopter, BLP is 30 degrees, another 30, 60, 90 triangle. What is the distance between L and P? Alright, well, I'm going to copy this picture, and I'm going to give a name to the length that I want. So we've got H up here, helicopter. We've got L, we've got P and B here with the ball. I got 30 degrees here, 60 degrees in total here. And I want the distance between L and P. So I'm going to call that X. Okay. And 400 meters was between H and B. Okay. So we could use trig, although if you don't need trig to know about the 30, 60, 90 triangle, just sort of a special triangle that we memorize. But if you have A, B, C, and you know you've got a right angle and you've got 60 degrees and 30 degrees, these guys are called 30, 60, 90 triangles. So the side length opposite 30 degrees is basically considered 1. Then AC, the hypotenuse, is twice whatever that length is. And over here we have root 3. Okay. So for any 30, 60, 90 triangle, the sides are in the ratio 1 to root 3 to 2. So, what does that tell us here? Well, if we were to call, so HP is then root 3 times X. BP is, so BP is the one opposite the 30 degrees, so we've got a 90 or a 60 up here. 30 here. So X is BP times root 3. So then HP is root 3 BP. HP is 3 times BP. HP minus BP, we were told that that's 400, but that's also going to be 3 BP minus BP, so it's going to be 2 BP. So 200 is the same as BP. And as we said, X is root 3 times BP. So you know, we might have to, if it's a written question, we got to set things up. So we might say let X be PL or something like that. But so the distance from L to P is 200 root 3. Okay. And that's all we were asked for, and we wrote up our solution. We used triangles, which are similar to the 30, 60, 90 triangle. You might have clarified a little bit. You might have written down these angles and explained it a bit, do some diagram chasing, but ultimately the essence of the proof is all there. Everything, I think it's all clear from there as long as it was written in the proper order. I know I sort of started down here and then started writing up here, but when you write up contests, make sure that everything flows, and if you have to write different parts on different parts of the page, put arrows to it so people can follow your work. All right, so up next is question number 5. Thanks for joining me for this question on the Euclid, and I'll see you for more Euclid next time.